Are you in physics? Yes or no? I assume the answer is yes if you're watching this video. And if the answer is yes, are you struggling with learning about Newton's universal law of gravitation? Well, fret no further. I'm here to teach you about Newton's law of universal gravitation so that you don't fail your test. To help you understand it a little better, I'm going to teach you a bit about the history of universal gravitation. So, universal gravitation originated from ancient philosophical ideas, but was formalized by Isaac Newton in the 17th century. Obviously, Newton wasn't the only person who had ever pondered gravity before. I mean, you're not the only one, buddy. But, there are two other people I would like to talk about, and those two are Aristotle and Brahmagupta. Aristotle was an ancient Greek philosopher who believed that objects naturally moved towards their place where they belonged, which was what he believed was the center of the universe. Now, this obviously isn't like he didn't have the right idea, but he was moving in the right direction. Yay! Let's say that. Brahmagupta was an ancient Indian mathematician and astronomer, and he said that Earth had a natural attractive force, which made objects want to fall towards it. And, well, obviously he was born in a time a little bit later than Aristotle, but he had more of the right idea, and more people kept adding on to it, and they laid the foundation for Newton to create the universal law of gravitation. The universal law of gravitation pretty much says that every object in the universe always attracts every other object toward itself. So all the objects in the universe are just attracted to each other. Like they're in love. Aww. Now, the whole law of universal gravitation revolves around the one gravitational constant. And this number is 6.6734 times 10 to the negative 11th power. And it's measured in newtons, but its units are cubic meters per square kilograms. And the gravitational constant pretty much determines the strength of the gravitational force between two objects. And it's just one number, so pretty simple, right? Wrong. There's also an equation that goes with universal gravitation. That equation is F equals G times M1 times M2 over R2, which sounds a bit crazy, but it's pretty simple when you break it down. All that means is that force equals G, the gravitational constant, times M1, the mass of the first object, times M2, the mass of the second object, divided by the distance between the two objects, squared. Don't forget to square your distance, ever. And this equation pretty much just tells you what the gravitational force is the two objects are acting on each other. So I pretty much just explained to you, in simple terms, universal gravitation. So we're done. No, we're not. We're not done, because I'm going to make you do a practice problem with me, whether you like it or not. Okay, so I cooked this neat little problem up all by myself. So here it is. What is the gravitational force between two objects of masses 30 kilograms and 70 kilograms separated by a distance of 2 meters? That's a lot of information, right? Wrong. You're overthinking it already. You just saw a bunch of numbers and you're like, oh my god, what does all this mean? Stop. I'm going to help you through it. So my first step that I like to do when I solve these problems is rewrite the formula, because it helps me see the letters and what I'm looking for. So I go ahead and rewrite the equation first. The next thing to do is plug all your numbers into your equation. So, remembering, the equation is F equals G times M1 times M2 divided by R2. Now, rereading the question, it's just asking you for the gravitational force. So, you don't have to do any rearranging your equation or anything. So, you keep the F. Your G will always be the same. That gravitational constant, it literally says constant in the name. It's going to be the same number every single time. So for G, you're going to want to put 6.67 times 10 to the negative 11 and your units. Write your units down. So newtons and then cubic meters and then the little slash, kilogram square. You have your first number already, and you didn't even have to look in the problem. Same number every time. Your gravitational constant is the same number every time. The next thing in the equation is M1. Go in your problem, look at the first mass it says. In our problem, it was 30 kilograms. So, go ahead and write that next. 30 kilograms. Keep writing your units. The next thing, M2, your second mass. Go back in that question. The first mass was 30 kilograms. What's the second mass that it says? 70 kilograms. Write that down. You're already done with everything in your numerator. Now, draw that line and divide that by your distance, which is 2 meters. So, write 2 meters in the denominator and square it. Always square it. Never forget to square it. Now that you have your whole equation written out, you can look at your units that you wrote out with it, and you can start to see that some of them cancel out. So in your gravitational constant, you have kilograms squared. And then in M1, you have kilograms, and in M2, you have kilograms as well. Kilogram times kilogram, that would be kilogram square. The kilogram square in your gravitational constant is going to cancel out with those two masses because they're both kilograms and you're multiplying them by each other. So you can go ahead and cross those out, not the numbers, just the units. Cross out your kilograms. So now you don't have to worry about kilograms. Now all you have are the newtons on the top, m squared on the top, and m on the bottom. Wow. You have m squared in your gravitational constant, and in your distance, you have m, but your distance is squared. So you also have m squared. So you can cross out that m squared. You can cross out that m squared in the top too. And now, guess what? You're just left with newtons. And what are we solving for? Gravitational force. And what is force measured in? Newtons. So that's going to be in your answer. Now you have your whole equation written out. All you have to do is plug the numbers into your calculator. And then you're done. So, when I plugged this into my calculator, I got around it. I got 3.5 times 10 to the negative 8th power. Newtons. Always write your unit. All it is, draw a little N next to it. That's literally it. Always write your units. Your physics teacher will slap you in the face if you hand them a paper and you don't have your units written. But you already knew that, didn't you? And guess what? No, really, I want you to guess. No, I'm kidding. I don't. We're done. We're already done. Did you see how easy that was? Don't overcomplicate physics. Just write the numbers down, plug them into the calculator, and you got it. I believe in you.